Well, the last two questions are standard deviation questions, and no, you can't use a calculator. Okay, they give you an approximate mean, which is approximately helpful, and you're going to have to round your information. Now, there's a couple things you can do, really. I mean, if you look at this, if you understand that standard deviation is the average distance from the mean, and you'll look at 7 prominently displayed among these numbers. Well, the difference between that and this is about 3. It's about 6. That's 2, that's 1, and then we have another 2. Your differences, with the exception of the 13, are 1s, 2s, and 3s only. You have one that's 6 units away. Now, people, let's take a moment there. If the average distance from the mean is what standard deviation represents, okay, standard deviation, the standard distance that these numbers are from the number 7. Okay, it's very likely going to be something that's this straightforward. If you've got a series of 2s and 3s and a 1 mixed in there, and your biggest value is a 6, the only thing that really makes sense in terms of the average distance from the mean is this one. It's the only one small enough. You can't even find a great distance that's even equal to 74, let alone an average of all those. So understanding the definition of the standard deviation is definitely a benefit. Now you can go through the process, and we're going to do that. Well, I guess we don't even have to do that. But over here, you've basically got 1, 2, 3, 4, 5, 6. You've got 6 numbers. James found the mean and standard deviation of the set of numbers above. He's adding 5 to each number. So if we add 5 to each number, to the whole set, you're going to get an 8, 11, 7, 6, 12, and 10. All right? You have a whole new set of numbers. Well, the average is hopefully, obviously, going to be bigger. And in fact, it's going to be bigger by the same amount that you added. So the mean is going to be larger. But are these, well, well, I'm not going to find the mean right now. Well, why not? 9, 10, 17, 22, 24. 24 divided by 6 is 4. So the average here is 4. Okay? Number directly in among them. Now we add 5 to each of these. The average of this is going to be 5 more than this. So the average is going to be 9. Okay? The mean will be multiplied by 5. I don't think so. Because if this is 4, x bar is 4, x bar here is equal to 9. That's 5 more. It's not multiplied by 5. The standard deviation is the difference that all these guys are from 9 any different than all these guys are from 4? You've got numbers that are 1, 2, and 3 that are just units below that. You got 5, 6, and 7 that are same units above that. Well, 9's right in the middle of these too. You got 6, 7, and 8, which are below 9. You got 10, 11, and 12, which are above. The standard deviation did not change. Okay. Well, since we brought that up, we may as well look at answer D. Standard deviation doesn't change when you add data to it. Now, if we multiplied, yes, the standard deviation would change by the same multiple. But the fact that we added those together simply meant the mean will increase by that amount, but the standard deviation will not change.